So let's look at implicit differentiation, and I will also try and answer your question. Believe it or not, you have been doing implicit differentiation all along without realizing it. When I gave you this, y equals 5x squared plus 2x minus 3, and I said to you, take the derivative. What is the derivative on the right-hand side? 10x. And then I've told you it's actually the chain rule. It's always been times the derivative of what's inside the brackets. Now, what's inside the brackets is just an x, and what's the derivative of x? 1, so we don't bother writing it. But you were doing the chain rule from day one. I'm trying to convince you of that, first of all. And then you said, okay, it's going to be plus 2, and again, times the derivative of what's inside the brackets, x times 1. You never bothered doing that, and then the derivative of a constant is 0. You never thought that this was actually 1y to the 1 power, but it is. You were doing implicit differentiation without realizing it. What you were really doing was moving the exponent down to the front and multiplying it onto the coefficient. What is 1 times 1? Times the derivative of what's inside the brackets. What's the derivative of y? And you wrote that as that. Now, you never realized that you were actually doing implicit differentiation to turn a y into a y prime, but you were. You were. Just didn't know it. So if you have something like this, okay, and you're going to take the derivative, you would go like this. It's going to be chain rule. Move the exponent down to the front, subtract 1 from the exponent, rewrite what's inside. Now I'm going to delete that 1 because it looks too much like a prime symbol and I don't want to get it confused. Times the derivative of what's inside the brackets. What is inside the bracket? A y. There's no bracket, but what's sitting there is a y. What's the derivative of y? Y prime. Okay? No, derivative of x is 1. What's the derivative of y? Okay? Then on the right-hand side, we're back in familiar territory. 6x, and derivative of constant is 0. This is what we mean by implicit differentiation. You have a y prime in your equation, but it isn't by itself yet. But you're in physics. Let's get the y prime by itself. How would I move the 2y over? Yes. Y prime, the derivative of that original function is apparently 6x over 2y, which can be tidied up, the 6 and the 2. Apparently, it's 3x over y. What that means is, suppose you wanted to find the slope of this graph when x equals 3. Okay? You'd first of all find the y coordinate that goes with it. You'd plug it. Now, let's use function notation. You would find f of 3 in the original function up here. 3 squared is 9 times 3 plus 6. Apparently, the point we're talking about is 3, 33. The graph goes through that point. What would the slope of it be right there? I would plug this into my derivative. Oh, I overshot. Into my derivative function. Apparently, the slope right there, it's 9 over 33, which does reduce. Apparently, the slope right there is 3/11. I made this up, so it's not a nice, pretty answer. Sorry, I made it up. But this is implicit differentiation. It says, look, when you're taking the derivative of a function with y, treat it like the chain rule. But when you're writing times what's inside the brackets, what's the derivative of y? Okay. And all we can do now is really kick things up a notch by bringing in quotient and product rules. For example, I have no idea what this is a function of, but I can find the derivative. Ready? Here we go. Product rule. It's really that times that. Are you getting 100% in calculus? then we're going to do this the long way. No, I asked that because there's some kids that can just see this and do this bang, bang. I never got that good. So what did I say? Product rule? I'm actually going to go off on the margin. I'm going to say u times v prime is u v prime plus u prime v, or the other way around, it doesn't matter. I'm even going to do more than that. I'm going to say, in my case, u equals 5x, v equals y. You okay with that? I'm just breaking it up into what the u v prime, the u times v actually is. Yeah, ask. Squared, thank you. I can't believe I botched a squared. It happens to all of us. Oh, and I would even say, so that means u prime is 10x times the derivative of x, which is just 1. Ooh. What's v prime? What's the derivative? Huh? Yes. And now I can plug and chug and substitute. Ready? What's the derivative of this thing here? It's going to be u v prime plus u prime v. That is what that becomes when I take the derivative. Now, you do a zillion of these and you can reach the point where you can do the product rule in your head. And in my prime, no pun intended, I could do that. Let's take the derivative of negative 3xy to the fourth. It's going to be the same pattern, so I'm not going to rewrite my original product rule. I'm just going to see if I can come up with my substitutions. I'll change colors. So u is going to be negative 3x. V is going to be y to the fourth. U prime is going to be negative 3. V prime is going to be 4. Y cubed times y prime times the derivative of what's left inside. It's the chain rule writ large. Let me pause. See Nevada? Move it down, rewrite it, subtract 1, times the derivative of what's inside. There it is. This is the chain rule. Okay? Put your pencil down. Ready? If I had given you this, x squared plus 6 to the fourth, and I'd said take the derivative of that, you'd move that to the front. Yes? You'd subtract 1 from the exponent. Yes? And then you'd multiply by the derivative of what's inside. This is what the chain rule says. So you'd multiply by 2x. Yes? Well, in this case, it's not an x squared plus 6. It's a y. Times the derivative of what's inside. What's the derivative of y? Y prime. No. It's not sneaky. You need to realize you've been doing it all along without realizing that you've been doing it all along. If you start to go down the rabbit hole and imagine all the invisible ones that are there that we never write, and you're always multiplying. When you take the derivative of x, you're always multiplying by 1. Now you just always skip that step, but you were, right? By the way, what's the derivative of 3? What's the derivative of any constant? Why? Because really, that's 3 times x to the 0. X to the 0 is another invisible 1, and you would move the exponent to the front. When you move the 0 to the front, what's 0 times anything? It's always, the chain rule is in everything. We're sloppy in how we write it. Anyways, so these first two became that, and then so this one is going to become, now I'm going to fit in the template, and I'll change colors again. The template is u v prime, so it's going to be negative 3x times 4y cubed y prime plus, now I can do this, I know you guys can't, but I can do this. Hang on, let me just pause this really quickly so they don't say any names. Hang on. So we'll continue. So, look up. This here is that plus u prime negative 3 v y to the fourth. And then on the right-hand side, what's the derivative of 0? Yeah, because it's really 0 times x to the 0 when you move the 0 to, which, again, is really becoming stupid and obvious and redundant, but yeah. Okay. I'm going to tidy this up a little bit. In particular, I think I can tidy this one up because I got a negative 3 times a 4. Negative 12. Okay, so I'm going to quickly rewrite this. It's going to be a 5x squared times y prime plus a 10xy minus 12xy cubed y prime minus 3y to the 4th. That equals 0. What are we actually trying to find? Y prime. Ready? I've snuck this in physics too. How many y primes are there on my equation? How many would I prefer? You know what? Let's get them to the same side. Actually, I'm going to leave the y primes where they are and then move the other stuff over. We've done this before in physics too. So I'm going to have the 5x squared y prime drop down like a domino and the minus 12x y cubed y prime drop down like a domino. And on the other side, I'm going to have a positive 3y to the 4th and a negative 10xy. You could have put the negative 10xy first, but I always move the negatives over first because I like to start with positives and then go negatives. That's just me being fussy. You okay with me so far? How many y primes do I have? How many would I prefer? It would be wonderful if there was a grade 9 mathematical operation that I could pull out of my back pocket and turn this from 2 into 1. Are you saying y prime is a GCF? It is. 5x minus 12xy cubed equals, look up. I missed a squared? Oh, I forgot the squared on the previous line. Hannah, I can't believe I did that. Thank you, thank you. You're writing so much stuff that I tend to eventually use ditto marks for the whole right-hand side of it. You can rewrite it if you really want to, but this often I got in the habit of just saying on the right-hand side, this is going to drop down, and it's going to drop down on my next line. I'll write it on my next line. How would I get the y prime by itself? How will I move that big, ugly bracket over? Yep. So final answer. This I will write out properly. Y prime is going to be on the top. I have a 3, a y to the 4th, a minus, a 10x, and a y, all over a 5, an x squared, a minus, a 12, an x, and a y cubed. That is the derivative implicitly derived. Why do we say implicitly derived? We had to get the y prime by itself afterwards by being clever with the chain rule first to get the y primes into the equation, getting them all to one side, pulling out a little clever math 9. Now, how would you then use it? So let's suppose they said, now find the equation of the tangent line at, I'm going to make this up. We're not going to do this because this is a hideous derivative because I made it up. But you might say, okay, what is the slope at x equals 4? Going back to the very original equation, this puppy up here, you would plug in a 4 and you'd have to solve for y, which would be very, very difficult to do. You need a computer to do it. But once you had whatever 4 comma whatever was, you would put those values into here for y and for x, and that would tell you the slope right there. Let's do a function that we actually know what it looks like so we can test if we're right. We're going to do a circle. And the circle is going to look like this. X squared plus y squared equals 25. You remember doing conics at the very beginning? This is a circle of radius 5. It hasn't been moved left or right at all because there's nothing in the brackets. I was nice. I didn't feel like going through it. Hasn't been moved up or down at all. Okay. So it looks like this. That's supposed to be a circle. Shut up. Okay. But here's what I want you to realize. Right there at the top of the circle, what's the slope right there for a split second? If I do this right, once I get my derivative, I should be able to plug in the point 0, 5, and I should get a 0 in my equation because I know what the slope is there. And what's the slope right there for a split second? Ooh, and what's the slope right there and right there where it goes vertical for a split second? We have a fancy name for that. Not as a number, it has a term. Begins with the letter U, then an N. then a D, then an E, then an F. Undefined. In other words, when we plug in x equals -5 or +5, we should get an error on our calculator in our derivative equation. This is how we'll know that this implicit differentiation stuff works. Conic sections are really fun to derive implicitly because you can look then, especially if you've got a good graph software like I have, you can graph the original and see, oh yeah, my slopes work. So you ready? Here we go. Derivative of 2x squared. Again, it's technically 2x times x prime, but what's the derivative of x? So we never bother writing that, but you were always doing the chain rule. You always were. Plus, what's the derivative of y squared? It's going to be 2y times y prime, and the derivative of y prime is not 1, it's y prime. What's the derivative of 25? Cool. I think I would now minus the 2x over. So I have 2y, y prime equals -2x. We want to get the y prime by itself. In fact, you know what? Even on this line, I could even be clever and go, ha ha, ha ha! The 2's will cancel, and I'll get y prime equals -x over y. Okay? So let's see if this works. At the top of the circle, what are the coordinates at the top of the circle there? What comma what? 0. So if I plug in 0, 5, don't write it down. Let's just do it. I said we should get 0 as a derivative. I get 0 divided by 5. 0 divided by 5 is 0. A 0 on the top of a fraction gives you 0. That also works down there. What's this point right here? 5, comma, how high? 0. When you put a 0 in the bottom, can you divide by 0? No, I'm looking for a word that begins with the letter U and has an N, and then a D, and then an E, and then, huh? And that match, you know what? This seems to very much match our derivative. Very much does. I know another point that works in this equation. The point 4, 3 is a point on this graph. Trust me, you get 16 plus 9, which is 25. This is a handy circle. I've memorized a bunch of the points. There's some nice points. So what would the slope be at 4, 3? First of all, look at my hideous picture. Is the slope there positive or negative? I better get a negative slope. Let's find out. Oh yeah, I get -4/3. I do get a negative. Okay. What about right here? Now this point here is -4, 3, which also works because -4 squared is still 16 plus 9. That also works in the equation. I get a -4, which is I do get a positive slope, which works. So this is really suggesting to me that I think we've done our derivative right. It fits the graph that I know. So now let's actually try doing some questions that you have, but we'll clone them. I don't know, I got to get the file open. Which one?
The
very last one.
For the second, or sorry, not the very last one, number 4, very last, so the second derivative.
I didn't take a picture of number 4. I only have 1, 2, and 3. Oh, number 3? And then what's the second derivative?
Yes.
Okay, what's the original function? Y squared plus,
Yeah.
is that, so is the original function y squared
X squared plus 4x.
equals x squared plus 4x? You ready? Y squared equals x squared plus, let's make it 8x. There, it's a whole new function. So this is not the answer to your question, but you can now try this on your own too. Let's take the first derivative. Are you ready? Here we go. What's the derivative of 2y? Sorry, of y squared. 2y times y prime. The derivative of what was inside the brackets. The chain rule, again, writ large. What's the derivative of x squared? And then the derivative of 8x? 8. Now, how would I get y prime by itself if I wanted to? Divide by. Okay. It wants the second derivative. I think finding the second derivative will be easier in this form than if I get the y prime by itself. I'm not sure. It's if I get the y prime by itself, I'm going to have a quotient rule because I'm going to have a 2y on the bottom, and I hate the quotient rule. So we're going to see. This here is a product rule. That times that. Derivative of u v all prime, it's u prime v plus u v prime, or vice versa. I'm going to try and do this one without writing all the subderivatives. I'm going to see if I could just use that template. So are you ready? U prime, what's the derivative of 2y? No, that would be for 2x. What's the derivative of 2y? 2y times y prime. Why does the first y stay? What's the derivative of y squared? The 2 moves to the front. You rewrite what was inside the brackets, and then you subtract 1 from the exponent. And then you multiply by the derivative of what was inside the brackets, which is y prime. We're doing the chain rule writ large. This is why I went on that rant about how when you wrap your brain around the chain rule, it explains an awful lot. Okay? Have I convinced you or no?
I thought you were doing the derivative.
Ready? Of this. Yes. So what's the derivative of 2y? Did I write a y? Did I write 2y? Oh, that's what you're asking. Sorry. 2 times the derivative of what's inside the brackets, which is just y prime.
Yeah.
So that is the derivative of this. That's the u prime
Okay.
times v. What's v?
Y prime.
Okay. Ugh, but okay. We can write that as a y prime squared, but I'll leave it as y prime, y prime. Then there's going to be a plus sign. Rewrite function u. Rewrite the 2y times the derivative of y prime. What's the derivative of y prime? That's what we're trying to find. That's what we're going to get by itself later on. Okay? Equal sign drops down like a domino. What's the derivative of 2x? Technically times x prime, but x prime is just 1. What's the derivative of 8? Yeah, really it's 8 times x to the 0. The 0. Again, everything is the chain rule. Okay. This is pretty good. How would I get the y double prime by itself? Yeah, let's do that first. So I'm going to have 2y times y double prime equals 2 minus 2. And I'm going to do this. I'm going to go y prime squared. I think that's a little prettier than y prime, y prime. I don't know yet. Oh, I forgot double prime. Sheesh. There we go. I missed the second prime there. And how do I get the y double prime by itself now? So I get this. I'm doing this just so I can fit this all on one page. Now this is still kind of yucky, and the reason this is yucky is while I have the y prime by itself, ugh. Okay, wait. See this line right here? Get the y prime by itself. So y prime is equal to 2x plus 8 over 2y. Is there a GCF on the top? Yeah. Actually, it turns out y prime is equal to 2 bracket x plus 4 over 2y. It turns out the 2's cancel. Okay? What does y prime equal? X plus 4 over y. What does y prime equal, Cassidy? Wherever I see a y prime, what can I write instead? When I see a y prime, what can I replace it with? When I see a y prime, what can I replace it with? See how we have to, it's going to take us a while to get there, and this example that I've made up may end up being much uglier than the one that you have. I think the one that you have, this might have completely canceled out, or I don't know. Anyways, so we're going to end up with this. The second derivative is going to be equal to, on the bottom there's a 2y, there's a 2, there's a minus, there's a 2, and then I guess it's going to be x plus 4 over y all squared, because it was y prime all squared. Could I tidy that up? This is where this example that I've made up is going to end up kind of ugly-ish now. But, well, yeah, I could FOIL x plus 4 all squared is x squared plus 8x plus 16. I could FOIL that out. The y squared would be on the bottom. I have a fraction inside of a fraction. I'm not wild about my final answer, but this is what happens when I make up a question. So let me look at yours again. I can't remember what yours was. Oh, no. When you go y prime, your y prime is going to be 2x plus 4 over 2y. The 2 cancels. You'll have x plus 2 over y. So you'll still have a term kicking around there. So mine's not much uglier than yours, but this is what you can do, okay?
There was one more on the
Yeah.
back, but I don't think you got it.
I'll borrow it,
Picture.
and I'll clone it. Find the tangent line, the normal line. Oh, this is a not too bad one. Oh, then we're going to go on a rant about that, my child. Darn it, this one I'm going to have to do the actual question because I don't have the tech on me right now to find a point on this graph. Okay. So it was find normal line and tangent line. Is that what it was? Actually, you know what? We find the tangent line first, then we find the normal line. My angel. When we say find the tangent line, what we're really saying is, oh, what's the point that they gave you? 1, 2. Okay? When we say find the tangent line, what we're really saying is this. Find the slope for 1, 2. And what's a synonym for slope in calculus? It begins with letter D. It's what you've been doing all the time here. Okay, find the derivative and plug in 1, 2. That's going to give you the slope. And then you're going to plug that into y minus y1 equals mx minus x1, where that slope is the slope, where y1 is the y coordinate that they gave you, and x1 is the x coordinate that they gave you. We're going to do that, but all we're saying when we say find the slope of the tangent line is find the derivative. We'll give you the point that it goes through. Plug in, and the reason, by the way, in the first, earlier, we only gave you the x value, and the reason was it was easy to find the y coordinate because the y was by itself. Here, this equation, is the y by itself? No, I need some software to if you told me, well, what if x is 3? I need some software to find what y goes with x equals 3, and I don't have that on me. So you ready? Let's find the slope. What's the fancy word for slope in calculus? Okay. I'm going to pick on you the whole way, Nevada. What's the derivative of 2x? Plus, read me this term. Just read me this term. What's the mathematical operation between the x and the y? This is product rule. You asked earlier, how do I know? Now, this is how I know. It's product rule. Okay? So, you ready? The product rule, this one I'll jot down. UV all prime, it's take the derivative times, and then rewrite, right? It's U prime, I can't remember, I might be changing the order that I'm writing it, but I always know it's derivative of one of them times the other one plus the derivative of the second one times the first one. It's whatever order. Okay. You ready? What is the first term? What's U in this equation? What's V in this equation? Ready? U prime, derivative of x. Woohoo! V. Because because I asked you to. Plus U. V prime. x, and this is what we're going to get by itself later on. Okay? Plus, what's the derivative of y squared? Not of x squared, of y squared, which is going to be almost the same rules with a twist. Equals, and what's the derivative of 2? Nothing. How many y primes do I have in this equation? How many would I prefer? Let's get everything else to the other side. This is where your physics formula manipulation certainly gives you a bit of a leg up on some of the kids. I guess it's going to be -2 and minus y. Ugh, double negative, but that's okay. I haven't made a dumb mistake, Hannah, have I? Okay. How many y primes do I have? How many would I prefer? It'd be wonderful if it was a grade 9 mathematical operation, right? Factor out an x, factor out a y prime. Ready? You guys have been in physics, so don't write this down. Factor out the y prime, imagine it. Just imagine it. What bracket would be left beside it? Can you imagine the bracket that would be left beside? How would I move that bracket over? So if you feel comfortable, you can, if you get good, say, you know what, y prime is going to be the -2, the minus y is going to be on the top, and there's going to be an x and a plus 2y on the bottom. There's a shortcut I was always okay with taking. This is the equation for the slope. We want to find the slope at 1, 2. You guys have seen that little vertical bar trick as a nice handy-dandy shorthand for substitution. So if you draw a vertical bar, that's an abbreviation for, and now we're going to substitute in, and then whatever we put next to there. So, what is y prime when I plug it? So it's going to be -2 minus 2 all over 1 plus 4. I think. The slope at 1, 2, you get -4 over 5? Nevada, what's the slope at 1, 2? So the tangent line, the line that hits 1, 2 at exactly the same slope, that equation is going to look like this. As a pattern, it's going to be y minus y1 equals m bracket x minus x1. This is point slope form or slope point form. I learned it as slope point form, and I think the new curriculum changed it to point slope. Anyways. Oh, they changed all sorts of terms. This is one, I think you might even have this. Does he have this on the formula sheet? I can't remember. This is a really handy way to write. This is how I write all equations of lines. Slope-intercept form, y equals mx plus b. It's really stupid. It only works if your y-intercept is a nice whole number. And most of the time, the y-intercept is a decimal. This version works as long as you know any point anywhere. I like that. It's much more powerful. What is the point that we know on this line? So, y minus 2, because that's the y coordinate. Don't put the first thing in there. A lot of kids put the x value there because it came first. No. Equals, what's the slope right there?
So, -4
Bracket x minus 1. And by the way, the reason it's y minus and x minus, that comes out of your in Math 12, the translations that you've been doing. Really what we're saying is start at 0, 0, but you need to move 1 right and 2 up in order to go through the particular line that we're interested in. That is the equation of the tangent line.
So we can just leave it like that, like we don't have to.
Ask Mr. Kamosi. I much preferred this because to me, I glance at this and instantly I know a slope and I know a point it goes through. I can graph this. If you get rid of brackets, and I'd have to rewrite it like this. So to me, and I don't know, maybe I'm in the minority in math, I don't simplify everything. To me, simplify should mean what's the most useful form. We're not done. This is the the normal line is, hey, what's that a symbol for, physics people? No? Connor, what? Perpendicular to the tangent line. You can write out the word perpendicular if you want to, but I'm going to use a symbol because I tend to abbreviate. Okay. And all that's going to change is the slope. It's still going to go through 1, 2, so it's still going to look like y minus 2 equals space bracket x minus 1. How do I make a slope perpendicular to another slope? Negative reciprocal. It's not inverse, negative reciprocal. So positive 5/4. If you can find the tangent line, the normal line is p. It's flip and change the sign of the slope. That's the normal line. Let's see if we're right. Okay. Is the y by itself? So this is not going to be implicit differentiation. I can get, well, actually it is, because I'm going to take the derivative of y using the chain rule, and it's going to be move the 1 to the front, subtract 1 from the exponent, you'll get y to the 0, which just vanishes, but you'll get times the derivative of what's left inside, which is y prime. So what's the derivative of y? Y prime. The chain rule, I start on the outer function. What's the outer function? What's the derivative of sine? Nope. Negative cos. And, look up, just watch. It's negative cos. Rewrite what's inside. That's the chain rule. And I always talked to myself when I did this. Take the derivative of what's outside, rewrite what's inside. Now, times, and if you want to, you can kind of check off, I've taken care of that. Now I'm on to this. Times the derivative of what's inside. What's the derivative of 4x cubed plus 5? And again, I've told you, you've been doing the chain rule the whole time. Technically, it's times the derivative of what's left inside. What's left inside? Just a plain old x. What's the derivative of x? 1. So you never bothered going times 1, but that's where everything always ended up. It always was the chain rule. The only thing, I think you'd probably move that to the very front. You'd probably write your final answer as negative 12x squared cos of 4x cubed plus 5. Okay. Derivatives. Sadly, they're the easy part of calculus. Antiderivatives. When I give you the derivative and say go backwards and tell me the original function, it's called integrating. The patterns going forwards, taking the derivative, are much cleaner. Going backwards, it's much more, like reversing a big chain rule is really tough. Right? In other words, if I gave you this, could you give me that back? It's a little tougher. Sadly, though, almost way more useful going backwards. Can I what? Oh, implicit. I got 5 minutes. Class ends at 10:35, right?
Yeah.
Wow, maybe I can do this. X cos 3y. I'm going to change it just slightly. X sine 5y. Ha 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 ha. See, this is how I clone questions. Equals y cos 4x. So here's a clone of the question. You can still do the homework. Ready, Nevada? I'm picking on you again. Okay? This is a product rule. That and that. It's x times that.
That's x after 4, right?
Yeah.
Okay, sorry.
No, that's my writing. Okay. So that first side is a product rule. You know what? U v all prime, that's u prime v plus v u prime. Okay. U is x. Oh, no, you're right. I wrote the same thing twice. Thank you. It's u prime v plus u v prime. Thank you. All right. U is x. What's the derivative of x? Okay. I'll erase that in just a second, but we did take care of that. V is, oh, rewrite it. So it's going to be 1 times the sine of 5y. Well, that was easy. Plus, Rewrite u, x. Derivative of sine of 5y. Well, we're going to start on the outside. This is going to be a chain rule. What's the derivative of sine? You know, look up. Say it again, you're right. Look up, look up, look up. Negative, and then I'll put the cos here. Rewrite what's inside. Times the derivative of what's inside. What's the derivative of 5y? And I'll get that y prime by itself later. Equals. The right-hand side is also a product rule. This time I'm not going to circle stuff. I'm going to see if I can just do it. It's derivative of the first term. What's the derivative of y? I'm going to have two y primes. I'll get them to one side and factor later on. Rewrite the second function. Plus, rewrite the first function, y, times the derivative of the second function. What's the derivative of cosine of 4x? Start on the outside. It's a chain rule. What's the derivative of cosine? No, just sine. Oh, sorry, you're right. You know what? I'm sorry. Derivative of sine is just cosine, isn't it, folks, back here? No wonder you were so confused. I apologize, Hannah. That was bugging you the whole time, wasn't it?
No.
Okay, back here, I said, what's the derivative of sine? And you said negative cos. It's derivative of sine is cos. Sorry, folks, I botched that. Derivative of cosine is negative sine. And so that I would just go, 'cause I'm not done. I would just scribble out the plus, make it a negative. Sine, rewrite what's inside. Times the derivative of what's inside. What's the derivative of 4x?
Just quick, in the equation above it says negative cos, that would just be cos then, right? Same as the derivative. So I'm just making sure.
I can't believe I did that. I think you're right. Derivative of sine is cos, not negative cos. Did we get it right earlier? We did another trig one earlier, didn't we? I can't remember now. It's been a while since I've taught calculus. Now, we're going to run out of time. The tone's going to go in 60 seconds. But just look up. You would get all your y primes to one side. So I think I would minus this. You know what? I would minus this less ugly sucker to this side. And I would minus the sine of 5y to the other side. How many y primes will I have over here? How many would I prefer? Factor and divide. Gosh, I can't believe I botched that cosine there, because I'm going to upload this video for you guys, and there's a mistake in it. But